don't mind.
Maybe you're an X-Man and this is your superpower.
Oh.
Can be called Pencil Man. No.
Anyone wants a pencil? I summon the pencil. I shoot out pencils from my finger when I'm hungry.
Yes. It's not. I know it's not quite Wolverine, but you know.
But it's pointless.
Minus 100 cool points for you. Yeah, that was pretty good, actually. All right. Engineers.
How do you like me now?
Have you ever tried Boston donuts?
Not yet. I've seen them though. No, I think my favorite is Offbeat Donuts so far.
I've tried it for the first time, just for yesterday.
They're good. They're good.
But they're too much.
They're good. They're worth it.
No, they're too much.
Offbeat and rolling donuts. But
I don't like rolling donuts.
I'll try Rolling Donuts next. But Offbeat is pretty good.
yeah.
Pretty
I
good.
heard the glaze is really good. Okay.
Everything in Offbeat's good. All right.
On the day.
Tumbleweed. Right. What we're going to do now is we're going to use some of the trigonometry rules that we've. We're going to use some of the trigonometry rules that we've learned to help us with integration. So, for example, I think I'll do firstly 1a and b. So, can you just write down once I took a picture? Hang on one sec. There we go.
Can use my calculator.
No. I just. Yep. Can you write down 1a? I'm going to do 1a now.
What lesson is this?
Oh yeah, this is
Continuation.
further integration using trigonometry basically to do it. So the reason this lesson is called trigonometric integration is because either the question or the answer has a sine, cos, tan in it. Okay, can I do the first one now? Right. So, 1a. Anybody have any ideas on what I could do by using one or more of the trigonometry identities that we've done so far? Any ideas? Yeah, could do double angle. I'm not so worried about the 2x. That isn't really a problem for me. It's the square that's unpleasant. What can I do about the square?
1 minus sine 2x square.
Yeah, but you just changed one square for another square. What can I do about the problem with the student? Well, you could replace them with another problem student. Just the normal. Oh, just the normal way. Oh, okay. Because I was going to do it the, abnormal way. What's the normal way? Hang on, Lee's talking. Okay, that's a start. Now what's next, Lee? Do what? Come on, Lee. We believe in you. What? No, we do believe in you, don't we, guys?
Yes.
Yeah. Now what do we do next?
Go China.
Yeah. Oh, you're letting Team China down. No?
You're our favorite engineer.
Not anymore. No. Anybody? Anybody else? You're not going to let Team Iraq win, are you? Come on. Iraq beat China? Okay. I was hoping someone would remember.
Compound. No.
Well, kind of. We did a lesson a few days ago where we changed a product into a sum. I'll remind you. For example, let's imagine you have cos A, cos B plus sin A, sin B. What does that equal? Cos.
Yeah.
Very good. And then what's cos A plus B?
That's compound.
The only difference is a minus. You remember this, of course. And then what do we do here? You add them. So you get 2 cos A cos B equals cos A minus B plus cos A plus B. Now, I'll make A equal to B. So then this is 2 cos squared A equals cos 0 plus cos 2A. What's cos 0? 1. And finally, I'll multiply by 2 and I'll change A to x. So I get 4 cos squared x. I'm sorry, I won't change that yet. 4 cos squared A equals 2 plus 2 cos A. And finally, I'll make A equal to 2x. So I get 4 cos squared 2x equals 2 plus 2 cos
2x.
Alright. Does this look familiar? It does, because that's what I have here. I have 4 cos 2x.
Can you move to the...
Well, I'm sure people might want to write this down first. So this is a helpful result.
So, what's the formula there?
I just used it there, the compound angle formulas.
But then you made A equal to B and...
I'm using my previous formulas to make a formula that would help me with this one.
So that's what we are supposed to do in the exam.
For something like this? Yeah, but there are other ways to do it. For example, I think you can use integration by parts as well. But because I'm putting this in the lesson with trigonometry, we want to try and use trigonometry to solve it. Yeah. Or Fuang, you could use that formula you told me about last time as well. You got that? Yeah. Emer had her pep talk with you? Yes. Did it pep you up?
She gave us chocolate.
She gave us lion chocolate.
Did it pep you up? She
Not
gave you
yet.
chocolates
Not yet, maybe.
during Ramadan.
I'll leave it alone. Not sure if that was supposed to bring us up or take us down.
Yeah, she forgot it was Ramadan.
Instead of that now.
She knows I don't like it, so maybe she was trying to help me. With everyone.
Okay, can I go back to the main question? Yep. So, are we just waiting for Yahya? No, we're waiting for Omar.
Omar, let's go with Ikram.
And Yusuf.
I'm on the last one.
One more sip of coffee. What's wrong, Lee? Bored? Continue?
No.
Hey. We're still waiting for Omar. W2F Omar, come on. What's up?
Welcome to physics.
Okay. So, basically, my problem here, I can now write it as integrate 2 plus 2 cos 4x. And now all of a sudden the integration has become extremely easy. Because this is just going to be 2x. Does anyone know or remember what happens here?
Minus
No. No, nearly. We forgot something. What's one? Yeah, no, what you say? I thought you said it.
the power. No, by part.
Don't forget to divide by this number here. And that's the answer. So actually most of the work, you see, that's why this lesson is inside the lesson on trigonometry, because this is more of a trigonometry problem than it is a calculus problem. Because most of the time is spent with trigonometry rather than with actually integrating. Do you get what I'm saying? Yeah? Do you get the idea? The method? So many blank looking faces. Anybody home?
Yeah, but this is it's so confusing.
Well, I said I'll do 2 of them. So the next one here is cosine. So what? Wait, before you start it, what compound angle rule will you need for cosine? Which one? Sine A plus B and sine A minus B. Yeah? Okay, can you try B? And you'll also note in part A, the A and the B were the same. But in part B, there are different angles here. Wait, before I can continue. So if I can give you a little tip, you should make this angle A and this angle B and just write them the other way. It's a little easier. It's a little easier to make the bigger angle to call it A and the smaller angle to call it B, because when you do the A plus B, A minus B, you don't get negative angles then. Do you want to give it a try, Andrew? Finished. You got the right answer? Go Team China. Wait. Alright. Anyone else finished except for D? Are you finished? Good man. What are you? Team Malaysia? Team Malaysia. Finished? Big Hero 6? Big Hero 6?
Yeah.
You like this movie? You like it? Did you see it in English or Vietnamese? That's okay. A bit of both.
I can hear better, but I can't
A
understand.
listening exercise. Is there any cinema in Ireland that has Vietnamese subtitles? None. Yeah.
Even the English.
Oh really?
Italian.
Really?
Oh,
I don't usually need subtitles for movies. My English is okay.
but you can realize it has platform in the movie, in the film.
It has what?
The word
Yeah.
or not?
Oh.
In the
No, some for only non-English movies there's English subtitles. Like if there was like a French movie. Okay. Can we try the second one now? Did you get an answer? Alright, let's have a look. Yusuf, did you get an answer for the second? Oh my goodness. This is quite concerning, guys. Cos x, sine 4x dx. You got an answer, Fuang. Okay. This is equal to 6 sine 4x cos x dx. And you know, sine 4x plus x equals sine x 4x cos x plus sine x cos 4x. And what am I saying? And sine 4x minus x equals sine 4x cos x minus sine x cos 4x.
Why don't you put A and B?
Oh, I just skipped that step because I'm just going to change A and B later to 4x and x because that's what I'm dealing with in the question. So I just skipped that step. So I get sine 5x plus sine 3x equals 2 sine 4x cos x. Now what should I multiply this by? 3. So then this becomes 6 and this becomes 3 and this becomes 3. So integrating this is the same as integrating this, which will be minus 3 cos 5x over 5 minus 3 cos 3x over 3, which of course cancel, plus c. This is a typical exam question. It's okay. Did you get this? Good job. Okay.
How many marks did this carry in the exam? Like
Hmm?
questions like this?
Say again?
How many marks with questions like this carry in the exam?
No, because you have that's a negative outlook, because you're thinking, how many marks have I just burnt on this question, right? That's what you're thinking, isn't it? Look at me. This would be about 4 marks.
And how many questions would we have?
This would probably be a section A question. Section A, I can't remember, it's something like maybe 13 questions, 14 questions.
And the exam's out of 100?
I have 125.
Oh, that's good. It's better than being out of 100 because then it gets rounded up to 70. Grades up to 70.
I don't know what you're saying.
Which means if you get, like, if it was out of 100, if you get 50, then you get 35 in the final.
What are you talking?
Yeah. The final is up to 70% from, like, the
Yeah.
grade you get.
Yeah. But rounding doesn't happen until after all your grades are put together.
Yeah, so what I'm saying is that if it was out of 100,
Yeah.
and then you get 50%
That's 35.
That's 35
Correct.
70.
And if it was out of 125,
That will be more. If you lose the same number of marks.
if you lost 50 marks.
Yeah.
Yeah, but I don't think it works like that. Like, if I give you a maths exam and you get 50% out of it, and it's 100 marks, so you get 50 marks. And then I give you the same maths exam, but I mark it out of 125, are you going to lose 50 marks or half the marks?
Yeah, even if you do lose half. Yeah.
It's the same thing.
Sure. But then there's a chance if you get
Cursed by percentages.
The correct answer would also.
Yeah, if you're right half the time,
Yeah.
then you get half the marks. Simple as that.
I need to study my probabilities.
You need to work on your percentages. Good thing that's not a big part of the exam.
I wish
Alright.
it was.
Okay. Now, number 2 should look a little bit familiar. You might have remembered it from an earlier lesson we did. There's a small rule here. The proof, I'm going to do it really quick. No, I won't do the proof. But I'll just remind you of the result that you had earlier in the integration chapter. I don't know if you remember this. 1 over x squared plus 1 dx. Does anyone remember what that integrates to? No. What? Not x. We did this lesson, I think, when we were doing integration of rational functions. Yeah. So what's new for today is this one. Go on, have a guess. Wait, did I type that backwards? I do, I'm so sorry. Wait, alert! Backwards, so sorry. Have a guess. What is this one? Good guess, but no. Now, I won't do the proof because the proof is the same. It's the same proof as this one here. And you recall that I said the proof of this one was on the exam once. So likewise, the proof of this one could be on the exam. And I'm deliberately not doing the proof because it's so remarkably similar. If you look back at your notes to review this, you see the key step here was to draw a triangle where you had like an x and a 1 here. It's the same idea, except the only difference is where you put the x and the 1. So in this one, what's different? Well, the x will be here, but the 1 is here. Yeah. So it's nearly 100% the same proof. You just make a small change on the triangle, and the result will give us this instead. I recommend you review that proof from your notes later this week at some point. It is something that could be on the exam. Okay. The only proofs that are on this exam are proofs involving trigonometry, and this counts as one of them because it involves a tan and a sine. Yeah? Okay. Can you write... Oh, sorry, do you have this new rule? Yes. And do you know what it is? No. No. I think, I'm not 100% sure, but I think the only difference is this.
So what lesson is it?
I think it would have been some lesson like integration of simple rational functions, perhaps. I don't remember. It was a little bit before the partial fractions lesson. Continue? Yeah? Okay. So I will now do, as an example, something simple like 2a and then something harder. So can you write down 2a?
These won't be given to us, like the formulas that... Okay.
No, those integrations I just wrote, I believe, are in the formula book, yeah. Yeah, you know, they are, yeah. So the ones on the screen are in the book. Yeah. Okay, got that? Let's have a look. Now, anybody except you, Lee, sorry, know what to do first. If you think back to that lesson, there was a special substitution here that's helpful. Oh, started so well, but not this.
Wait, 16 over something. I can't remember. 16 over minus...
You have the right words, but not in the right order.
Minus x squared over 16. Or 16 over minus x squared.
Or neither of those?
Square root.
Oh, we're getting closer.
Square root, yeah.
That's the one, yeah. So, for this lesson, it's in the previous lesson, I believe the substitution was square root first over second. Whereas in this one, it's second over first. Or maybe more precisely, the x part over the non-x part, generally speaking. So, we use this substitution, which is equal to this. So you know then that makes du dx equal to a quarter. So that means dx is equal to 4 du. So this will become 1 over square root 4 du. And this will be 16 minus x squared. Now what does x equal? If I look at this. 4u. Yeah, so what, Lee, so what does x squared equal? 16u squared. So this is 16 minus 16u squared, which is 1 over square root 16, square root 1 minus u squared, with a 4 du on top. I took the 16 out, factored out. What's square root 16?
4.
And now I have my rule. This is sine inverse u, which is sine inverse x over 4 plus c. Final answer. Yep. Yep.
So it's sine inverse du, not u.
Sine inverse u.
How does it become x over 4?
Ah, because u is x over 4.
Oh.
No? More difficult one now? Probably need to write that down. Did you write it down? Do you want to write it down?
No.
But you should.
The previous lesson was integration of simplex rational function.
Yeah, that's what I thought, yeah. What's your secret, Omar? He's the only one that ever seems to have energy in class. Is it because you're not wasting energy at home doing homework? No, seriously, what's the secret? Look at all those look at those sleepy heads. Is it because you're by the window?
No, because when I wake up, I can't sleep in class.
Oh, once you're awake, you're awake.
I'm awake, yeah.
So does that mean once you're asleep, you're very asleep, yeah? It's like, hey Omar, wake up, there's a fire. Okay, you got that? Yep, alright. Let's look at a more difficult one. What? What's wrong, dude?
I don't like that. That's du over root 1 minus.
Oh my goodness, okay. If you want, you can rewrite as 1 over root 1 minus u squared du.
Oh. So where does the du go?
Doesn't go anywhere, it's still there in both cases.
Yeah, but like after, like in the second step.
From here to here.
Yeah.
Because integration.
Oh, okay. Okay.
Integrate this. Dude, give me a break. Alright, cool? Yes, okay. Continue? Yes? Alright. Let's look at a more difficult one. Let's jump on down to one like H. No, I don't like the big numbers in it, that makes me sad. N. Can you write that one down?
Is it weird to walk in the street with like 5 1?
No.
It's like you're walking in place everyone knows it.
Maybe you guys just look suspicious.
Maybe.
Were you speaking Arabic at the time?
No, like we were walking in the street. And like
Were you looking suspicious? Were you walking suspiciously?
There was a lady that like was waiting for the signal to turn on, and
She saw you guys coming and walked away?
She saw faces, so she came and she looked at the donuts. She was like, I couldn't resist. It looked so good, and
Maybe you guys are just good looking and people. No, sorry, that's I take that back. Right, and 1 over square root 240 plus, I realise it's the same as m, 8x minus x squared. Alright, who's got any bright ideas here? Lee?
Put get the minus outside.
Yep, good. First step, get the minus outside, okay. So that's minus x squared minus 8x minus 240. No?
Yeah, but put the 240 outside.
Outside what? The minus? Okay. Yeah, what's this called? You do know, Lee. What's it called? I'll give you the letters. Nobody else say it except for Lee. CTS.
I'll tell you, Lee, if you teach me more.
And I'll give you in the middle word there. Oh, come on. Yeah, the square, yeah, so the first word, completing the square. Yeah, this one. Please remember these words, Lee, please. Thank you. Right, so if we complete the square, what will we get here? X minus 4 squared, and that'll be x squared minus 8x plus 16 minus 256. Yeah. So that's equal to square root dx over root, and if I put the minus back in, I get 256 minus x minus 4 squared. And the u should equal what? So the u should equal x minus 4 over 16. Right? So the u should equal, the du dx should equal then 1 over 16, and also that 16u equals x minus 4. So I get here now this is equal to 16 du over square root 256 minus 16u squared. Now what's 16 squared? 256. And what's the square root of 256? So basically you can take this out and cancel it with that, just like last time. And just like last time, this should always happen. The reason we make this substitution is so that this always happens. So once again we're left with this. So once again we're left with this. So once again we're left with sine inverse u, which will be x minus 4 over 16 plus c. And that's not an accident. This happens because I do this. Not an accident.
So we cancel 16u
with the 256, yeah. Because the 256 is under the square root. Square root of 256 is 16.
And what about the other 16?
But that 16 first has to be squared and then square rooted. 16 squared, 256.
Yeah.
Root 256, 16.
So you cancel it with the top one. And the u.
Oh, the u isn't, u's still there. What's wrong, Fuan? You're pointing, but no questions. It's kind of strange. You know, it's like if I did this. There we go, yeah? This two? That's a square. Huh? All of them? What do you mean? Yeah, 16u squared, yeah. Oh, you're asking me what it is. My handwriting's messy. Sorry. It's like this. 16 du over root 256 minus 16u squared. Is that okay? Continue. Okay.
Could you just read out the answer?
The answer is sine inverse x minus 4 over 16 plus c. Yeah? Good enough? Could do it a few more minutes. Sleepy, sleepy, not sleepy, sleepy, not sleepy. Ooh, just about not sleepy, definitely not sleepy. Oh wait, is he asleep right now? So I realised you stopped moving. Okay, continue. You got that now? Yep. Right. Can you write down A and I'll do it? What do you think? Can't see really. Squared. Too many video games? No? Too much using your phone? Yeah. Okay. Let's have a look now. Square root integrates 16 minus x squared dx. Who's got an idea here? Go on. I know someone has an idea here. Go on. Say it. Say what we're all thinking.
I don't think I'm thinking
Why, what are you thinking?
Oh, cancel.
No.
X squared equals u.
No.
Can't
That's
you
not what I thought you were thinking.
Can't you just square root?
No. This
Oh.
not equal this. So not that. Any other ideas?
Change how it's written.
Yeah, how? No. No. So, is a negative and minus not the same thing?
16 minus x squared in a bracket to the power of a half.
No. I thought somebody might suggest u equal to square root x squared over 16.
Why? It's not a fraction.
Good, because that's wrong. Any other ideas? I shall tell you. So what we do here, we draw a triangle. And we call this side x. And we call this side 1. And just so you know, for these questions, I am mistaken. We call this side 4. And if you're wondering where I got these from, the 4 came from here, and the x came from here. Because now, if I have a 4 and an x here, how big will this side be? Square root. Yeah. 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 So this is the same as that. And that's on purpose. And we call this angle U. Now, sine U equals x over 4. So that means x equals 4 sine U. So what does dx du equal? Yeah, go on. I heard it. 4 cos u. So that means dx equals 4 cos u du. So this becomes this. Now what's the problem here? Now, what's the problem? What's wrong with this integration? Why is this integration not halal or kosher or whatever word you use in your religion? What's wrong with this? Correct. Correct. You're not allowed to mix X and U. Mixing is not allowed. So we need to replace which one?
16 minus
True. Which one? This one. Now we can replace it if we look at this triangle. What would be useful to use here? Sine, cos, or tan of u? Yeah. What does cos of u equal? The square root part over 4. This root part over 4. That's cos. So what does the root part by itself equal? Yeah, this will just be the same thing as 4 cos u. So now the question has become this. Integrate 4 cos u du, which is now 16 integrate cos squared u du. Does this problem look familiar? Yeah, it's literally the very first problem I did today. So what do we use here to solve this? Our buddy compound angles. Yes? Now if we want to speed things up a little bit, you can actually use a double angle here. Watch this. Cos 2x equals cos squared x minus sine squared x. You remember that? But what does sine squared equal? 1 minus cos squared. So this is equal to 2 cos squared x minus 1. That's cos 2x. So that means cos 2x plus 1 over 2, that's equal to cos squared x. And if I multiply both sides by 16, I get my result. 8 cos 2x plus 1 is equal to 16 cos squared x. So that there, I can put it in here. That will become 8 integrate cos 2x, cos 2u plus 1 du. So back to the action here. The 16? No, because I said here. Yeah? Yeah. Okay, so let's integrate. That's 8, and what does cos 2u become?
Sine.
Yep.
2u.
Plus
C. 0 C.
u plus c. Yes. Are we finished? Is this finished? No, why not? You have u's and we should have x. And by the way, this is a double angle formula. So we can change this into 8 2 sine u cos u over 2. And what happens here? 2 is cancelled. So this is 8 sine u cos u plus u, and we'll just stick the c at the end, it doesn't matter. Alright, now let's use our brains.
8c.
No.
Oh no.
The c, no. The c is a constant. We don't need to perform any algebra on it. It's only standing for a constant at the end. We don't. It's a word. It's not a variable plus a constant. Trust me on this.
Will it be wrong if we write it as 8c?
No.
Okay, then I'll write that.
Don't trust me then. That's okay. I thought after all this time I would have earned your trust, but no, I guess not. Okay, sine u.
So my personal instruction.
Whatevs. Sine u. Very good, thank you, Fuang. It's x over 4. Okay, fine. Cos u, square root 16 minus x squared over 4. Now, what about u? Well, you actually have a choice. You can go with sine inverse, cos inverse, or tan inverse to make the u. So you could, what would be the easiest one? Yeah, because, yeah, well, you don't have, you have sine inverse x over 4 plus c. So this will simplify to 4 by 4 is 16, so that's a half x root 16 minus x squared plus 8 sine inverse x over 4 plus constant. And that's the final answer. This, unfortunately for you, is a section A question. So it's not something you can avoid in the exam. It's long, it's tricky, and the only thing that they may do to help you, not that it's much of a help, is they might tell you this in the question. Also, they might put some limits here too, just for fun, like 0 to 1 or something. You know.
It looks long.
It looks difficult?
Long. Over long.
No, it just has one extra step. It is more difficult because it's longer.
Yeah.
Yeah, so write that down. There we go. And that's not even the full page because you had this on the side as well. But sometimes what they do for these questions is they break it into two parts. So part A of the question would be something like, prove that these are the same. That would be like part A. And then part B of the question would be, using your result from part A, solve this. Okay, write that down, please. Go on. Be strong.
I got you something.
What?
Okay.
I saw that before.
No.
Okay, so we just write in the second part.
Huh?
We just write this.
Yes, write everything down. You can write part A down when you finish this if you like, just to let me know. You wrote this down then? You're looking at lols.
My whole family has prostate cancer.
I don't see how that's funny.
Yesterday, no, I'm sure. Yesterday, and I was working at one of the shops where...
The shady donut shop, I told you.
Donut
Yeah.
shop was even nothing about prostate cancer, so I helped him this donut.
Nice. Did he appreciate it?
He was really happy about it.
When we were buying it.
I covered something that he was donut.
So when we
Wow.
And then I asked him,
Some sentences I never thought I would
It
hear.
was like, it's delicious with a wink.
Oh, I'm disturbed. I'm so disturbed.
You want something like that. But the perfect match for me.
No, if you somehow like the
Yeah, I don't know how the accommodation managed to match you up so perfectly with this host family.
no, if only you
Did
saw
you have to answer some questionnaire beforehand? No.
how the guy sold us the donut. There's the first I was like, I'd like to have one of these. And then he was like, would you like to have a big one and a smaller one? First I looked at him, he was like, the biggest one you have.
Oh, goodness. Wow, yeah. This class is strange. That's a story I'll never forget now. Yeah, that is a shady donut shop.
Wait, did you say I'd like to have one of these? Just making sure.
No, I have to resist the urge not to make this worse and start. I'll keep my comments to myself. Resist the urge. Okay, did you write that down? I'm going to go to the A part. Yes? Go left?
Maybe zoom out.
Go right? I just wrote that for Faisal. What does that stand for? That's C. Yes.
The square root 16 minus x squared. So it becomes 4.
The square root that? How does it become this?
Top left.
Here?
Up.
Here?
Up.
Here?
Up.
Here?
Up.
Here?
Up.
It's like it's
Here.
challenging.
This here, cos u equals square root 16 minus x squared over 4. So 4 cos u equals square root 16 minus x squared. So that becomes that. No? What am I missing here? Is it? Are you sure? Can I scroll to the left for the part A part? Yeah, here?
Yeah, I have also a picture.
Okay, well here, write this part down too as well, please.
Oh no! it was like the.
Tone it back, Faisal. For such situations, it's easy for it to become too dirty, okay?
Oh yeah. I was about
There's
to
a
do
line.
that.
There's a line to cross. You need to know where that line is. Well, nobody told me this.
No, you should go and ask. Like, go buy one and see what he'll tell you. Because this will be the funniest thing.
No.
The testicles were made out of marshmallows. It was like they stuffed with marshmallows.
OMG.
I was about to buy a donut and then I was like, what's it stuffed with? He's like, I just like the testicles, it's stuffed with marshmallows. I was like, you know what, thank you.
See, it's shops like that that give the West a bad name, okay? Alright, do you have this A part written down?
Yes.
Yep. Okay. Now, this lesson is quite tricky, and you can see that there's more difficult ones here, which I haven't done, but I think you can do. For example,
Oh yes, perfect.
yeah, no, not yet. Wait. For example, number H here. Oops. H. What's different, and what will you need to do? Well, it has an x in it, as well as an x squared. So,
Can you use a triangle here?
no, something before the triangle. Complete the square. Complete the square. Complete the square. Yes, for H. Now, I want people to try these for a few minutes before we go to the next section, if there is time for the next section.
What would be the computer square?
Can you show her what it means? No. How on earth that's complete the square, I don't know. Lee will give you an example of completing the square, won't you, Lee?
Yes.
Yes, you will, Lee. Good. Good. Can you open up Moodle and try these for a few minutes, please? Let me just see how many lessons we have left to do in the maths.
That's called computer square? No, it's a...
What are you saying is complete the square, by the way?
But that is the formula.
Yeah.
And you make the formula to expand.
Yeah.
And that's called computer square.
Fuan, completing the square is doing this.
Exactly the thing. Oh, no.
This is called completing the square. Yeah?
Oh, square.
Huh?
Oh, square.
Completing a square instead of the square.
Oh, square.
Completing of square, completing the square, completing a square.
Oh.
This one? Because the da is for this question. No? If you said complete an a square, I would still understand you. But the reason for the T is because you're talking about this question.
Is any.
What
Yeah.
about the normal
What? But it will always be this question. You know, if I said complete the square for this, then you're completing the square for this question.
If we told you to complete a square,
Yeah,
then
you can make up your own example.
Exactly, make up your own question.
Why not completing this square?
Yeah.
But
Why are we talking about
completing this square.
Too much sibilance.
Completing this square. Completing the square of this quadratic. Yeah?
complete that?
Guys, you're thinking way too much about this. Can you open up Moodle and try these for a few minutes, please? Thank you.
Is the second one complete off square?
That's not a real term.